OpenSciEd, Energy Grid Calculator Walkthrough, Student-Facing Video. A spreadsheet document shows the Energy Grid Calculator, including sections for grid estimates, current plants to demolish or keep, plant quantity, maximum production and supply after wire losses, carbon emissions, and land use. The plant quantity numbers are highlighted in yellow.
When you first open your copy of the Energy Grid Calculator, it will look something like this. These numbers here serve as an estimate of what energy sources are currently used to provide electricity to people and businesses in your area. And once you have your copy, this will serve as a computational model to help you quickly try out different changes to the energy grid and compare them to your current grid using measures like reliability, supply and demand, carbon emissions, and more. In reality, your electric grid is connected to a much bigger network than just your city or even your state, but this calculator helps us think about choices that grid operators have made and how they affect us. On the Current tab, these first four questions are really just for getting started, but the creative work is going to be on these other Solution tabs at the bottom. In general, you should only have to change the yellow numbers, and if you try to change something else, you're going to get a warning that looks like this. If you ever see this warning, you should always click cancel. That way you won't delete any of the code that makes the calculator work behind the scenes. So let's take a look at how these solutions work. If I scroll down, I can choose to demolish plants that are currently in operation. So for example, I could demolish a coal plant, and you'll notice I'll see a lot of changes up here. Changes to reliability and also changes to carbon emissions and cost. I can then add plants up here to make my grid more reliable again. So for example, I might want to add back 2 natural gas plants, or perhaps I want to add a wind farm of 500 wind turbines. Every single choice I make is going to have trade-offs. So winterizing these wind turbines is going to cost a little bit more, but it'll also make my grid a little bit more reliable. If I was to build a nuclear plant, that makes my grid very reliable, but the cost goes up considerably. If I was to choose to build that plant outside the city or inside the city, that may have impacts on people's health. It's also going to impact how much energy is lost in those wires, because as we know, more energy is lost to the surroundings when the wires are longer. Notice if we do add some wind and solar, we are going to have to think about how to store that energy, or else when the wind isn't blowing and the sun isn't shining, we'll have periods of time where some people don't have the electricity they need, which is not reliable. Down here, we can add lithium-ion batteries, which is one storage solution, and that will increase the amount of time that people have power. But then if we scroll down, we're able to see even more options. So we can add flywheel battery storage or pumped gravity storage as well. We can even have other upgrades to the grid. For example, adding thicker power lines or putting those power lines underground. So in general, this calculator will help you keep track of the numbers, but it's still your job to think about what the numbers really mean. If I add a coal plant, for example, you'll notice the global life cycle land use will go up considerably, but it doesn't tell us what is actually happening on that land. Later on, you'll present your solutions in more detail using sources that you've already seen in your class, so you'll want to start thinking about that now. These are the basics, but there are opportunities to go even deeper. If you want to compare different solutions to each other, there's an opportunity to do that on Solution 2 and Solution 3. Both of these tabs give you a lot more detail about where these numbers are coming from. And if you want to go really deep, you can look at the Background Data tab, which gives us peer-reviewed or government sources for all of the numbers that are being used to make these calculations. If you're just trying to get started, focus on the Current tab and the Solution 1 tab. And work with it, and you'll get the hang of it gradually.
The video ends. OpenSciEd.